Holy cow, you guys. It is the last chapter. First part, 12A. We're starting right where we began with reflections, rotations, all that good stuff, okay? You're going to want to have a ruler of some sort. So if you need to, pause or stop this and find some sort of a straight edge for you to write with. Otherwise, we're going to continue. We're going to talk about an isometry. An isometry is just simply a transformation that does not change the shape or the size. So we've already talked about these. These are reflections, translations, rotations. These are all called isometries. The reason why is because not only do they have the congruence, but we also have something called congruent transformations or rigid moments. They're motions, sorry. They're solid motions. One's being flipped, one's being turned, one's being slid. These are rigid motions. I need you to remember, a reflection is a transformation that moves a figure, which is the pre-image, by flipping it across a line. So for instance, if I were to have a line here, and let's say this is my image, this is my pre-image, the rotation would flip it over this line. So if this were A, this would be A prime. If this were B, this would be B prime, C, C prime, D, and D prime, okay? A reflection is an isometry, so its image is always congruent to the pre-image. All right, so just a review here. A reflection, a reflection is just simply a transformation across a line called the line of reflection. So the line of reflection is perpendicular bisector of each segment that joins each point. So if I start with point A here, and I reflect it over to A prime, okay, this line of reflection is a perpendicular bisector of the line that joins. This line right here is a perpendicular bisector of the line that joins these 2 points. So I want to know, are these reflections, yes or no? Well, let's take a look. The first one, we're taking the blue and we're flipping it over to the red. If I flip this over, can this be a reflection? No, I do believe this piece would have to be over here, right? So this would be no. Here, if I were to take my blue and flip it over my line, would I get the red? Yes. I would like for you to pause, please, and do these last two. Come back, and then we'll see if we have the same answers. All right, so this first one's a no. This is actually being turned because this ends up down here. This one ends up down here, so this would have been a rotation. And this one's a yes because this would be the line of reflection. All right, so we're going to use that definition of a reflection to help us draw the reflection over a line. Okay, so this is where you're going to need that ruler that I said. First, what's going to happen is you're going to copy the triangle down, and hopefully if you printed out the notes you already have a copy, but you're going to copy the triangle, the line of reflection, and then I want you to draw the reflection on the other side. So what's going to happen is you're going to take and you're going to plot your points at your vertex right here, here, and here. You're going to draw, using your ruler, a line that's perpendicular to this line. So number one, through each vertex, draw a line perpendicular to the line of reflection. Okay, so that would be like this. And hopefully I can do this without a straight edge. A line here, this would have to be perpendicular. A line here, perpendicular. And a line here, perpendicular. Okay, that's step number one. Step number two, you're going to measure the distance from the vertex to the line. Okay, and then you're going to put a point the same distance on the opposite side. All right, so we're going to measure here. Using your ruler from here to here, I want you to measure. Then I want you to put a point from here to here that's the same distance. Okay, likewise, from here to here you're going to measure and put a point that's the same distance. From here to here you're going to measure and you're going to put a point that's the same distance. Once you have that, you'll be able to connect those dots and draw your image. So here's your pre-image, your line of reflection, and you went through, you should have measured the distance and came up with your image. I would like for you to pause, please, and do the same thing with this image here. All right, so here I copied my vertices, measured across the line, and then drew in my image. All right, let's do this problem. It says 2 buildings are located at A and B. They're to be connected to the same point on a water line. Where should they connect so that the least amount of pipe will be used? Okay? So what we're going to do is, first of all, we're going to take A and reflect it across the water line. And we know how to do that. Okay? We're going to take and make a perpendicular line, and then we're going to redraw A prime, same distance. Okay? Then the connection will actually be where this intersects the line. So what we're going to do is we're going to take our ruler and we'll be able to draw from here to here and figure out that this will be the best place to connect to the water line to make sure that we have the least amount of pipe possible. All right, last slide. When we're dealing with the coordinate plane, there's rules, okay? When we're dealing with reflections, if we reflect across the x-axis, your pre-image, the only thing that's going to change is the sign of your y. If we're reflecting across the x, the only thing we're changing is our vertical distance. So your y ends up becoming the opposite sign. So for instance, if you started with 1, 2, and you reflect it across the x, you end up with 1, -2. If you reflect across the y, the change would be the horizontal distance. So likewise, if you have your pre-image here, 1, 2, and we change our x coordinate, we'd have to do the opposite, -1, 2. And if you reflect across this line, y equals x here, what's going to happen is you're going to just flip-flop your x and your y's positions. So if this was at 1, 2 to begin with, and we reflect it across, we're going to end up at 2, 1. So looking at this example here, it says reflect the figure across the x-axis. If I want to reflect it across the x-axis, this is my rule. My rule will take your pre-image and change it so that the y is the opposite sign. So let's take a look. Let's follow the rules here. At x, we start with 2, -1. So this should become, now remember, the only thing we're changing is the sign for y. This should become 2, +1. Y is at -4, -3. So at y prime, -4 stays the same, but the 3 becomes a positive. And z is at 3, 2. So z prime, the 3 stays the same, but the 2 becomes the opposite sign, a negative. We're going to plot these, and we're going to show our reflection across the x-axis. So this is going to be my pre-image. It's going to be in red. X is at 2, -1. Y is at -4, -3. And z is at 3, 2. All right, so I'm going to draw this. This is my pre-image. And now we figured out our coordinates for our image. X prime is at 2, 1. Notice it just reflected right across. Y prime is at -4, +3. And then z prime is at 3, negative 2. And if I connect these dots, boop, sorry, this shows your reflection across the x-axis. Okay? You will be allowed to write these on a note card. Reflections, I would just write this whole thing, reflections across x-axis, y-axis, and then the xy, because we're going to do reflections, translations, and rotations, and they will all have their own little rules. So if you come up with a note card and have them on their own little separate places, it'll be a lot easier for you when we take our test, okay? All right, please make sure that you come with questions for tomorrow.